Hello, Algebra 2 students. This is Mrs. Sather. Today we're going to be talking about simplifying rational expressions. And first, it might be helpful to know exactly what a rational expression is. So, a rational expression is a quotient of two polynomials. In other words, it's a big fraction. It's just like every other fraction you've ever seen, just probably uglier. Normally, rational expressions have an x in the denominator. It can be like x minus 7, or it could be something with a higher degree like x squared minus 6. So the basis of this unit is that we're going to take everything you ever knew about fractions and we're going to apply them to big boy and girl polynomials. So one of the first things that you learned to do with fractions when you were younger is that you learned how to simplify them. So if you take this example 1 fraction, 9 over 24, one of the first things that you probably learned to do was to figure out how to reduce it or simplify. So you did that by thinking about all the numbers that you knew of that multiplied to be 9. So lots of times, 3 times 3 was probably the set of factors you were thinking of. And then you went through your head and thought about all the factors you could think of that multiplied to be 24. Now about this, it would be kind of nice to think of a factor that included one of the factors we just found from the numerator. So for 24, we probably want to think about 3 times 8. So then whenever you're looking at that, you might notice, aha, look, there's a 3 on the top of this fraction and a 3 at the bottom. What happens is that we go ahead and we cancel those out. If you divide 3 times 3, you end up getting 1. So 3 divided by 3 is 1, 3 divided by 3 is 1. And now we just kind of look at the rest of the problem. At the top, it turns into 1 times 3, or just 3, and at the bottom, it turns into 1 times 8, or just 8. So now we have a simplified fraction. That's the basis of everything we're going to be doing today. We have 2 more problems that we want to work through just to kind of see how that works out. So on problem number 2, or maybe 3 problems, I think we'll see. We'll see how far we go. So example 2, we have a negative 2x plus 10 and a 3x minus 15. All right, so one of the things about simplifying fractions is that you probably want to make sure that if there's whenever you're finished with your dividing out something, that your x term is going to be positive. So when you look at negative 2x plus 10, I really want to have a positive x when I'm finished. And I know that other than that, I can divide 2 and 10 by 2. So let's go ahead and take that negative 2 out so that what I'm left with is a positive x. I will be left with a negative 5, but that's okay. I just want that x that's right there to end up being a positive number. So let's kind of make sure that that happens. All right, so then what we want to do is go ahead and factor the denominator. So if I look at 3x and negative 15, I can divide both of those terms by 3. 3x divided by 3 is x, and negative 15 divided by 3 is negative 5. All right, so now we look for things that are the same. It could be simply the numbers out front. In this case, negative 2 and 3 are not the same. Sometimes it turns out to be those bigger expressions, like x minus 5, that turn out to be the same. And so we can do the same thing that we did before. We can go ahead and we can just cancel those out. So get rid of the x minus 5s, and you end up with a nice friendly fraction, negative 2 over 3. Now these would be all good and wonderful, except for negative 2 over 3 isn't exactly the same as negative 2x plus 10 over 3x minus 15, because there's one place on that big fraction that if I replace the x with a certain number, I would get 0 in the denominator. And chances are, whenever you were in elementary school, if you saw something like 4 divided by 0, your teacher said, oh, no, never do that. That's a bad idea. We don't want to divide by 0. And that's because functions are actually undefined if you divide by 0. So over here, we want to make sure that this little piece doesn't get the wrong number to make that entire denominator turn into a 0. So when a value for a rational expression as undefined. That means that the denominator is going to be equal to 0. So if we look at that same thing, if we were to take the x value in example 2 and make it a 5, you'll get 3 times 5 minus 15, and that would turn out to be 0, which would be a problem. So for our answer up here, we also want to say that x can't be equal to a positive 5, otherwise we will have issues, like a 0 in the denominator. And now everything's all good. It all works out. Just make sure you don't look at the value x is 5. All right, so let's try another one. This one requires a little bit different factoring. We just factored out a greatest common factor, or a GCF, on the last problem. This one is one of them where we're going to do that kind of factoring where you end up with the 2 sets of parentheses and 2 different binomials. So what's kind of nice about this problem, if you look at the numerator, it's got x squared. So that means if you wanted to, you could set up one of those little x things that we used to do, and you could find something. I usually put the multiplication on the top, something that multiplies to be 2, but adds together to end up being positive x. So when I think, or not positive x, probably positive 1. Let's change that real quick. You want something that multiplies to be negative 2 and adds to be 1. So that ends up being the numbers 2 and negative 1. So in this case, we can take our top fraction and top of the fraction and say x plus 2 times x minus 1. We can also do the same thing on the bottom. If you see that little x squared, the leading coefficient of this polynomial is a 1. If you don't like doing the x thing that I sort of set up a minute ago, you can always do what I've done before in class. And you find 2 numbers that multiply to be negative 3, but also add together to be your term in the middle, which happens to be positive 2. And then turns out if you take a negative 3 and a negative, or positive 3 and negative 1, sorry about that, you will get the terms we're looking for. So now we end up with x plus 3 and then x minus 1. Okay, so now you should be thinking, just like we did on the first couple of examples there, you've got an x minus 1, x minus 1. Those are going to cancel out, so we don't need those anymore. Go on. All right, so our final answer, our simplified expression, is going to be x plus 2 divided by x plus 3. Then we have to go through and take care of that restriction business. Restrictions would be when your denominator turns out to be 0. So if x plus 3 was 0, x would be negative 3. If x minus 1 was equal to 0, then x would be a positive 1. All right, so our restrictions, we definitely do not want x to be equal to a negative 3 or to a positive 1. All right, last example for the day. Simplify and find the exclusions to the domain. All right, so on this particular problem, you'll notice that our leading coefficient at the top is not a 1. So we can't just do the format of factoring that we did before. We need to do the kind of long factoring that I know some of you just love, but hey, it's not bad. We got time. So if we multiply our first term times our last term, we end up with negative 20x squared. Okay, so now we need to find 2 terms that are going to multiply together to be negative 20x squared, but also add up to be the term in the middle. So this is a little different from the factoring we did on the last problem, because it's not just that negative 10 at the end, it's that negative 10 times the term at the beginning. Okay, so I think if we work this out, if we go with a negative 5x and a positive 4x, we multiply and get negative 20. If we do negative 5x and positive 4x, we can add them together and we can end up getting a negative x. All right, so now what we're going to do is we're going to take our our original problem, 2x squared, and the minus 10 piece from that. And we're going to end up taking our terms that we just found. I'm going to put the 4x here and the negative 5x there. Put it all together, and now we're going to do some factor by grouping. So if you look at your first two terms and your last two terms, we're going to factor those out. So our first two terms, we're going to factor out a 2x, leaving us with x plus 2. We're going to look at our last two terms and factor out a negative 5, leaving us with x plus 2. And now you probably noticed this parenthesis and that parenthesis match, so we're going to write that down. We are technically factoring that out. And then those other things that are left, the 2x and the minus 5, they are going to go together. And hooray, hooray, the top of this problem has finally been factored. All right, now the denominator looks a little weird. The denominator is not in standard form. It would be nice if it were. So if I were to take a look at this x, it's a positive x. I'm just going to move it in front of that 2 so that it looks like it's kind of in the right order. That's much better. So now whenever we go to the business of canceling, can we find some things that match? Well, I see an x plus 2 up here. I also see an x plus 2 in the denominator. That sounds awesome. So let's cancel those out. And it turns out that what is left at the end, if these are canceled, remember, they don't really just vanish into the great abyss of nothing. They actually turn into ones. So you have 1 times 2x minus 5, which would just be 2x minus 5. In the denominator, we have a 1, but we know from elementary math that we don't have to write the denominator if the denominator is only a 1. So there's our simplified expression. Now for the fun part, what can we not put in the denominator? If I take my little problem of 2 plus x and set that equal to 0, looks like I'll be subtracting 2 from each side. So I really don't want x to be equal to 2. So I'm just going to say x is not equal to 2. And now we have our problem completed. So hopefully that made some sense. If you'd like to see more examples, there are lots of videos on Khan Academy. This sheet is linked to Canvas, and so you can click on the links there, or you can maybe get creative and write them down. Anyway, they're linked to Canvas, so you can go ahead and take a look at any of those as you proceed down the list. This is kind of a summary of some of the things we did today. I didn't do quite all of them. You might want to take a look at the common binomial factors and maybe some of the higher degree terms, just to kind of get some more practice with different types of factoring. So don't forget to do the practice problems assigned for today, and we'll see you later. Have a great day. Bye.